Everybody's ready? Sweet. All right. Hi. All right. So this one is building a better BGP lab. We'll get in a little bit. I'm not actually going to build much of a lab. You're going to do all the work. So who am I? I'm Greg Sowell. I have a couple of certifications. I work for a data center group, so I do a lot of infrastructure management, right, in this 100% SLA hitless environment, so I've got a lot of experience doing that stuff, as well as working on generators and chillers and lots of things I never wanted to have to deal with. Also do some consulting a little bit. I've been better about it lately, so a lot of your emails have been going back to you in a timely manner. Also an author for lynda.com, LinkedIn Learning, so big fan of their platform. It gives me a bigger voice to get my message out. I get to talk about MikroTik occasionally on there. I sneak it in whenever I can. Let's see. So another group I'm very proud to be part of is the Brothers Wisp. We do a podcast. We also have a Patreon. I'm going to go ahead and plug that there. So it's every 2 weeks we put one out, and it's just industry blah, 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 scuttlebutt, stuff like that. We talk a lot about MikroTik, other wireless vendors as well. Steve Gilbert, one of our brothers, actually helped me build this presentation. He did kind of the web back end, so I wanted to give him a big shout out for that. Also, if you see any of the other guys that are here from the Brothers Wisp, be sure to say hi to them. You got Wilson, you got Alex Hart, you got Miller over there. There's a few of us. Thomas is hiding out by the Unimus booth. All right, so assumptions here. You're familiar with the MikroTik interface. You guys are obviously here, so you know what MikroTik is. You're familiar with dynamic routing of some sort, right? Probably OSPF. It usually works in conjunction with BGP a lot. You also have some understanding of what BGP is and how it operates. But really, this is going to be kind of your catalyst to figure out how to better work with BGP, right? At least that's the hope. So what are some common uses and advantages? I only have one bullet point here showing connecting to upstream ISPs or exchanges, right? That's commonly what we use it for. You can use it a lot in your internal infrastructure, but this lab is really focusing on your connection to internet providers and how you sort of test and build and manipulate your routing based on that. You can control your IP advertisement, right? To me, that's one of the big powers of it. Whenever you first start out, you're just going to get DIA, direct internet, from one of your local providers, and you've only got one path. Maybe you'll get two, but now that addressing, your public addressing, isn't accessible via both of those, right? And when you do BGP, you have your own IP space. It gives you more power to advertise that out. So when somebody starts acting up, you can basically take them out of your mix, right? Or influence the flow of traffic in and out a little bit better. Traffic control, inbound and outbound, obviously, right? So I want to be able to make sure that I have some traffic preferred on this side versus that side. You can help kind of load balance your links, things like that. You can also do denial of service mitigation, right, with triggered black holing. I know we've had previous mums in the past where people have talked about that, so I'm not going to beat that one to death. Selective manipulation through communities. So communities are sort of arbitrary values that you can assign to routes that you're going to send out, right? So if I have, say, Talia is one of my upstream providers, and I don't want my address space going to Verizon Business through them, I can put a community string on my route, send it to them, and they won't propagate it to that one peer, right? So it gives you a lot of interesting power inside of a provider's network. You can actually sort of put your hand inside their network and control what your routing is going to do. So it's pretty cool. So there are a couple of different ways you can get your routes from providers. One is just get a default route. So what scenarios is that a good use case for? If you only have one upstream ISP, why do you need the full internet route table? It's not going to really provide you any additional control. Also, if you have a lower power router and it just can't handle a lot of routes, this is going to be easier on it, right? You're not having to compute all of those routes. You're not having to store all of that stuff. So next, some providers will also give you the ability to get partial routes. So a lot of times that's, say, in your region, say North America, you'll get the /24s for your region, and everything else would be aggregates from international routes. Normally, if you have multiple ISPs, this is going to be at least what you're going to be looking for is partial as well. Again, I say little international traffic. I think most of us here in North America have very little international traffic, unless you happen to be in a college town, which one of our major exports now is education, so you're going to have a lot of international students, so just sort of keep that in mind. I also recommend pulling default as well when you pull your partial routes. I'll talk more about that in a minute. Tom Smith would argue with me on that, and he has in the past, and he will continue to. But then comes the real power of BGP, where you get the full feeds, right? So you get every route this provider knows from their perspective, it's coming to you. This is really great for best path selection, right? If you have one provider that's sending you a /22 and another one that has a couple of /24s, you're going to send that traffic out of those /24s, right? So somebody's obviously advertising more specific routes from a certain direction. They're doing it for a reason. Why not take advantage of that, right? It is going to require additional resources on your routers, right? Every additional route you store takes more RAM, right? And as you build up all of these routes, whenever the BGP best path selection process happens, it's going to take some additional CPU resources to compute all of that. So you've got to bear that in mind. The more routes you have, the longer it's going to take for you to accept all of those routes, right? If your router goes down and you've got a lot of full feed peers on that, it's going to take significantly longer for him to load all those backends, right? So sort of things to remember. And again, even with a full feed, I recommend pulling the default route as well. And this is why I recommend pulling the default route. So if you have any customers, like I do in a data center environment, that happen to peer with you via BGP, they've got their own IP space. A lot of times, if you're, say, a WISP or a smaller provider, they're going to want to use you as just a backup link, right? So they may only want the default route from you. They've got a primary provider, and you're a failover. So a common scenario you see people do is default originate always with their customer peers, which means I will always send a default route to them. Now, what happens if something unfortunate occurs in your network where you lose, say, your only upstream peer? You're still sending them default, therefore you're going to black hole all of that traffic they're sending to you. But if you're accepting default from your provider and then you're just re-advertising that to them, if for some reason the worst case scenario happens and you lose all of your upstreams, you're no longer sending that default to them and you're not going to black hole their traffic. And say you have a bank or a financial institution that's using you, I think they're going to be a lot happier with you if the route just goes away, as opposed to you black hole their traffic for 45 minutes while you get everything resorted, right? So just something to keep in mind. And Tom couldn't argue with me on this point. So not to say he would admit that I won the argument, but he quit arguing. So border router design, I think if you've got multiple ISP connections, you should have multiple border routers. I'm not saying you have to have one for every upstream connection. I'm just saying you need at least two. For obvious reasons when you start looking at it. Fault tolerance, right? So if I lose any one piece of my infrastructure, I'm still maintained by the other provider, right? Routers break. Anything man-made is going to break. So just be prepared for that. Also, at some point, you're going to have to update the version of Router OS on your router, which means you got to reboot it. So if you've got more than one backboard border router supporting those ISP streams, you're still going to be maintained during those events. I know we announce maintenance windows to our customers, but I still never want them to have downtime, right? Even in a maintenance window, I always try and keep everything as maintained as I possibly can. It also spreads the load across multiple routers. Say you've got 6 ISP connections with full feeds. One router is going to compute that so much slower than if you split that out into multiples, right? It's going to be a lot easier. And best path still works in this scenario. All of your border routers just need to be peered together, and they'll still share that information. They'll still, router 1 will tell router 2, hey, I've got a better path for this, and router 2 will accept that. So all traffic that comes into router 2 for that destination will move over to 1 and go the way it needs to, right? So a lot of advantages to it, with not a whole lot of additional complexity. So my design's done. You know, I've done everything on paper. I've done all my diagrams. I would always say diagram your networks first. Whenever people ask me for help, that's always the first thing I ask them for is a diagram. And then 2 days later, they build the diagram and provide it to me. So do the diagram first. It's going to be so much easier for you. I've developed my configurations. I've got everything done in my routers. How do I test this stuff, right? So traditionally, we didn't have a method to, I've got a lab where I've never done BGP, and I need full feeds in to test how my infrastructure is going to, what's it going to do, right? There are some various ways. I think Kevin Myers from IP Architects made kind of a virtual machine that will give you a bunch of pseudo full feeds, right? They're not real routes. So I thought, wouldn't it be interesting if I could give you guys live feeds into full routes? So I did. I wrote this interface where you come in to my webpage, you follow this, this URL, and this is the part Steve put together. All you have to do is put in your name, email address, and you make up whatever passwords you want. It's going to send you an email that's got connection information. So it's going to give you an autonomous system number, a private one. It's also going to give you 2 usernames for my 2 different peers. So I'm giving you a full feed out of Brian, and I'm giving you one off my Houston infrastructure, and I've got multiple providers. So you're going to end up with somewhere around 680,000 routes from each one. After that, we're going to create a tunnel, a simple L2TP tunnel from your lab. I'm going to show you how to do it. And I'm not going to do it live because I'm not a crazy person. I will let the video do it for you, and I'll just narrate. So you go to L2TP client. I always like to give things names that make sense. So if it's an L2TP interface, I name it L2TP dash wherever it's going, right? And so in this instance, my first router, and whenever you go to the URL, it gives you diagrams and spells all this stuff out very easily. So r1.gregsowell.com. Always got to be pushing that brand, right? Got to brand yourself. Username, it's going to be your AS, and then if you're going to router 1, AS R1. Right? Pretty straightforward. And then I put in a password here, and I'm not going to tell you what my password is. It's not complicated. Yeah, I'm not worried about it. Google knows all my secrets. So the tunnel will come up. You can check. It's actually got the remote address right there. That's what you're going to peer with. So you're creating an L2TP tunnel, then you're peering with my side of the address. Everything's pre-configured in my routed infrastructure so that as soon as you bring your side up, your tunnel, and then you peer, it's already ready, waiting for you. So the next part is to create a BGP peering session. So tunnel endpoint, which we already saw, which is going to be 100.127.0.0, and your AS was emailed to you, 65.0.0.2. Not that I don't trust I could do this stuff live. It's just hotel Wi-Fi is a little shaky. So you can't do a route to a DNS name, so you got to ping it first to figure out what it is. 209.189.250.27. I'm sure Disher still has some of those IPs memorized. Create a nice static route. So why are we creating a static route for that tunnel endpoint? Anybody know? Because when you pull in those full feeds, you're going to have a better route for that destination through the BGP tunnel. So it's going to try and send the tunnel through the tunnel, and that doesn't exactly work. So you need a static route for that. So put that guy in place, and then we can go to routing BGP. And the first thing you're going to want to do is change your default instant autonomous system number to whatever was provided. In this instance, it's 65.0.0.2. Go into peers. We'll create the peer. Again, give it a name that makes sense. If you're ever going to call in outside help, you want them to immediately know, hey, this goes to this router or this goes to that provider. Put in the remote IP address. Again, it's the tunnel endpoint IP, 100.127.0.0. And then remote AS is always going to be the same thing for router 1, 49.64.998. At some point, I'll verify it. See, tunnel endpoint right there on the PPP interface for L2TP. And I should be able to click OK. Give it a second, you see it establish, and it starts pulling prefixes. So the routers I'm actually using to peer are CHRs. I give them like 4 cores and a gig of RAM. So it moves pretty quick. This is a CCR 1036. Now, you saw that CPU only looked like it was 2%, but whenever I go system resources and look at the CPU, one processor of that Tilera is pegged, right? So all these BGP feeds are always going to hit a single processor. So even though it looks like your router's not taxed, one CPU is cranking away really hard to pull in this full feed. So always keep that in mind. If you have 4 full feeds, those are all going to get split across a single CPU. So it's just going to take that much longer. So you can see some examples. I'm just doing a IP route print. You can see some of the routes there pulling. Next hop is going to be that point-to-point interface. Show IP route print detail. You can actually see some of the autonomous system numbers, right? You can see everything you're hopping through right there. You know, so you can see the AS path attribute being built. So you can actually have real full route feeds. A caveat to this is be sure not to use this in a live network. Make sure it's absolutely off to the side, because if this becomes best path to your network and you try and send stuff through this tunnel, I drop everything that's coming through, right? I'm trying to protect everybody from each other. The only thing I actually allow through the tunnel is some ICMP. So you can legitimately do trace routes through this, right? So you can see sort of what it's going to look like. But yeah, I protect everybody from everybody else, or protect you from yourself. So this is what the network currently looks like, right? You've got a lab device, one static route, a tunnel up, and a BGP session. And that would take all of 30 seconds for you to put in place. So let's kick it up a notch and do a couple of ISP connections. I'm doing it to a single CCR 1036, right? Give you kind of an idea. So on that last router, pulling the full feed took about 1 minute, 15 seconds, right? I think that's pretty acceptable. See what happens once we pull in full feeds from both of these guys, right? So this time we're going to create the static route first, create the L2TP tunnel, and then throw in the BGP session, and then also do a little bit of troubleshooting. Wait for it. There it goes. So there's 680,000 routes, which means if I go to IP routes, that's not going to work anymore because Winbox doesn't want to load that many in there. So you're going to want to put in that static route via the command line, right? Just a simple destination and gateway. Same thing. L2TP client. I don't know why I showed this twice. You guys get the idea, right? It all works the same. But at some point, I'm going to add a looking glass onto this. I'm going to do a web-based. I was thinking about giving you guys access to the routers, and I thought, you know what, that's maybe a bad idea. I mean, I trust you guys in this room, right? I mean, we're all friends, but this guy's out on the internet. I don't know about that. Yeah. So if you guys have any looking glass suggestions that you actually like, web-based open source, let me know. So second connection, he's going to go 100.127.8.0, and I just cheat and copy here. Any good network admin does more copy and pasting than hand typing. Keep down those human errors. When you're creating the peer, name it something that makes sense. I'm going to paste in the address. This guy's autonomous system number is going to be different, right? So it looks like 2 different ISPs for you. 64999. I create it, watch. Idle goes to establish. I start pulling routes. Everything's great. And then wait for it. Everything's not great. It breaks. So why did it break? It's because I limit the number of routes you can send me. So I don't want all you yahoos sending me tons of crazy stuff, so you can only send me 20 routes, which means you're going to need to put some filtering in front of your BGP. Right now, it's pulling in all the routes from Peer 1, and it's trying to send those over to Peer 2. And to protect this environment, just like any ISP, I'm going to limit what you can send to me. So I'm going to create a quick route filter, and I like to make these really easy for me to understand too. So this is from me to the ISP, right? Make it make sense to anybody that looks at it. So I'm arbitrarily picking a network, when I know people hate when you do this. You're not supposed to do this. But just for the lab environment, feel free. 9.9.9.0/24, that's my new subnet I'm going to advertise out. And then I'm going to put in a block. So anytime you have something not selected, that means everything, right? So I just leave it blank and put a discard all at the end. And then I'm going to associate that new filter outgoing, right? So this basically means from me to this peer outgoing, run it through this filter. Something of note, watch this first peer. He's live. If he doesn't have a filter selected and I add a filter, what's going to happen? It's going to reestablish that peering session. You're going to drop everything and it's going to come back. So don't do that in a live network. And then I'm going to crank this guy on. All right. You see him starting to crank up. If you watch the timestamp for uptime, you can see I kind of skipped through the video to not bore everybody to death. But we're almost at a minute, and it's only 73,000 routes on one peer, right? 'Cause as you bring up additional peers, it just takes so much longer for this stuff to process. And again, system resource shows 2%, CPU, that one proc's pegged, right? So you'd still be forwarding traffic just fine, but you're just not going to have those routes very quickly. There we are, 5 minutes, and we've got full routes, right? So it went from 1:10 from a single provider to get full routes to 5 minutes for 2 providers. So definitely keep that in mind. So a CCR versus an x86 or CHR, x86 or CHR is going to calculate that stuff so much faster. Always keep that in mind. So those are going to be preferred for border routers that have a lot of peerings. So I looked at an IP route print from my CHR that's acting as the peer to you, and you saw I didn't see anything coming from you. Why is that? It's because until you inject your route into BGP, you're not going to advertise anything out. You're either going to do that with a network statement or you're going to do that with redistribution, right? As soon as I put that in there, I tell it to resend all, and then give it another go, and then magically the route appears in here. And again, you can do kind of like a print detail to see exactly what is being sent. So anything you do to manipulate that will show up in here. Gives you a good conduit to what you're doing. All right. So a little bit of stuff you can do. Now that you've got the full feed in, and I want to play with it, I want to see what I can do, what are some of those things? You can manipulate local preference on routes coming in, right? So this gives you the ability to change the best path selection process. I think it's acronyms like in NOLA or something like that for best path. It's like, is the next hop reachable? And then it's going to look for weight and then local preference, right? There's all these things you can do to manipulate which route gets selected. Higher is better with local preference whenever you set that. It's also transitive. So if I set local preference on router 1 in my network, every other BGP peer inside of my autonomous system knows that same preference as well. So let's do a quick lab on setting local preference. And like most things in BGP, it's all done through route filtering. So I'm going to do route print, arbitrarily pick the first route I see. So it's preferring router 1, right? The little A over there on the left between the 1 and the route means active, so that's the one that's chosen. So I'm going to manipulate it so that it will use router 2 instead. And again, it's done through filters, so I'm going to create a new one. This one's going to be for router 2. So I want to manipulate the NLRI, the network layer reachability information as it comes into router 2. So I'm going to say for this subnet, and again, I gave it a good name, R2 to me. Easy to remember what that's going to do. Accept it, BGP action, change local preference to 150. Most vendors default local preference to 100. So if you go 150, you know you're safe. Then OK. Then I need to apply it to the peer real quick. So it's going to be the in filter for this guy. Then give it the good old OK. That peer, again, since there was no filter, he's going to drop everything, reestablish. So be cautious when you're doing this in your live networks. I skip ahead because I didn't want to wait for the full feed. So I'm just cutting that out of the video, but you do still have to wait for the full feed to come in. And you can see it now changed which route is preferred, right? A simple way to do that in your network. You can also adjust weight, but weight only affects this single router, right? I could choose which route he wants to take on this router, but local preference actually advertises to everybody in my network. And you can see right over there on the right, BGP local preference 150. Like magic. So what's something else you can do prepending outbound? So how do I affect traffic coming into my network? Right? Again, it's affecting the best path selection. So the path attribute, AS path, how many ASs there are in the path. You artificially make this route look farther by taking my autonomous system number, 65002, and you just add it a bunch of times at the beginning. Sort of think of it like the way RIP does hop count. It makes it look more hops away, right? BGP is a path vector protocol, so instead of looking at router hops, it looks at entire autonomous system hops, right? And so I'm just artificially inflating that, making it look further. This is really going to be useful when you're trying to manipulate how traffic comes into your network, right? So if to ISP1, I don't want anything to come in there, I just make it look artificially farther away, everything will come this way. If ISP2 fails for any reason, a long path is way better than no path at all, so your traffic will then continue to reroute and come back into the primary ISP. Use this quite frequently. And guess how we do it? With filters. So create a new, or rather I'm just going to modify that existing filter for outbound for the 9.9.9.0, and you change set BGP prepend. There was an interesting portion of Europe that went offline due to the way MikroTik implements that. So you put how many prepends you want on there, and somebody put their autonomous system number in there instead. So it prepended several thousand times, I think, and it took down some European countries, I think, from that one. So use caution. I'm pretty sure they have that fixed now. But yeah, you can see my prepending out now from that ISP's perspective, right? So if I set 3, that's how many hops away it's going to look, right? It doesn't. So in like Cisco, whenever you set prepend, if I set prepend 4, it will take the original and then put 4 on there, so it's actually 5 hops away. In MikroTik, if you put 3, it doesn't take the original and then prepend, it just takes whatever number you put in there. So, any questions as far as this goes? The BGP feeds are full feeds, they're free. I'm anxious to see people get in there and actually start using it. I've only got one other person using it. I want a stranger to get in there. Yes, sir.
Wait, sorry, wait for a moment.
Oh, yeah. If you just go to gregsowell.com, at the top of the page, it says BGP Lab right there. So you can just click that. So you don't actually have this, you don't have to have this ugly link right there, but it is in the slides.
On the prepending stuff, I'm noticing more and more US IP ISPs. The tier 1s, the level 3s, and those are ignoring prepends in their effort to shove traffic around. So if you see that prepending is not working, it'll show up in their looking glasses and stuff, but more and more are just dropping it. They're stripping it off for their traffic engineering.
And the internet, I think you guys have always heard that it's a best effort service, and that comes to your peerings as well, right? So as soon as routes or NLRI leave your network, it's sort of up to the provider what they want to do. If they have a cheaper transit link or a more preferred transit link, they can strip off your prepending. They can strip off your communities. They can do kind of whatever they want, right? In your terms of service, there's no guarantee that they're going to adhere to anything you're sending them, right? So it's sort of, I mean, it really is best effort. I think whenever you're doing this testing in the real world, not in the lab scenario, I'm going to have a looking glass for you to use, but my favorite is routeviews.org. They have a ton of routers that you can connect to that have hundreds of peers. So anytime I'm making a BGP change live, I already have a connection to RouteViews, and I'll do show IP BGP for whatever that subnet is. And I'll do a pipe include and look just for my autonomous system number, and you can see 50 feeds scroll across, and all of their paths to reach you. And so if you're doing prepending, it may not show up from all of them, right? Because in BGP, if a router gets best path from somebody else, he's not going to advertise your crappy path to anybody else, right? He's only going to send out his best path. So you're not going to see that coming from everybody, but there'll be at least 3 or 4 peers they have where you'll see that prepending come through, so you can actually verify it in real-world scenarios. And honestly, you have to argue with your upstreams, right? The burden, the onus is on you to prove them wrong, right? So it's never their problem. You have to white paper them to death. You have to give them all the evidence stacked up, and route views is a great one because nobody can dispute what you're seeing straight off of their site.
Greg, did you say you have a looking glass server or you're working on one?
I need to put one up.
Okay.
I'm being, not to say I would ever wait to the last minute to put my presentations together, but some stuff came up, and maybe I finished this a couple days ago. So I need to get, I just want like a simple web base where you can go in there and look for your stuff. So that way you prepend. I want you to be able to prepend. I want you to be able to send communities. I want you to be able to put anything you want on those routes, those 20 routes, no more, otherwise it shuts your peer down, and see all that stuff actually change. I want Steve to start using them in his class. I want all his students to connect. Any other questions? No? Well, one last thing is, let me skip really quick to the end. 19, 20, 20. Wow, I had a lot of slides in this one. Go me. Shake my hand, talk to me, say hello. This is the whole reason I come to these things. Anybody else that you've ever seen or heard on the Brothers Wisp, say hello. These vendors, these tremendous vendors that are out here, they are a valuable resource. Go and talk to them. They don't show up here just to hang out in Baltimore, right? They come to meet you guys. So be sure to do that. Appreciate you guys. Thanks very much.